Alright, we're going to start this problem, or this video, with problem number 11. And so when we're trying to solve this, we are going to factor out what they have in common. So since both terms had sine in common, we wind up with this situation. So I've got the sine of x is equal to 0, and 2 cosine of x plus 1 is equal to 0. Subtract 1. 2 cosine x equals negative 1 divided by 2, and the cosine of x equals negative 1/2. Since we're doing this in degrees, you want to make sure your calculator is still in degrees. If you do sine negative 1 of 0, you find out one of your answers is 0, and if 0 is your answer, you always want to check the other side, which is at 180. So when I put the sine of 180 in my calculator, that gives me a second answer. So from this side we have 0 and 180. On the other side, so I guess we want to know where the cosine is negative, and that is in quadrant number 2 and quadrant number 3. When I do inverse cosine of 1/2 in my calculator, they will tell me that the answer is 60. So that's going to be each of my reference angles, which means one of my answers is going to be 120 because we're 60 short of 180, and in the other one we have 60 here, which is 60 past 180, which is 240. So my four answers are the four that are boxed up. For problem number 12, we have the cotangent of x times the sine of x equals the cosine of x. So generally speaking, we change cosine, or cotangent, be sine over cosine, which I believe is the basic trig identity they're talking about, because the sine x is canceling is not a trig identity, and so we wind up with cosine x equals cosine x. For number 13, they said we're in the first quadrant, and they said the sine was 4 over 5, and when I do my Pythagorean theorem, and I subtract 16 on both sides, x squared equals 9, so x equals 3, so that one right there is 3. So when we do the sine, we do 2 sine theta cosine theta, which is 2 times 4/5 times 3/5. And since these are all numbers, you can put it in your calculator, and you'll wind up with 24 over 25. For this one, for the cosine of 2 theta, I'm going to use 1 minus 2 sine squared theta, because they gave us what sine is. So 1 minus 2 times 4/5 squared. And once again, because we have no square root, we're just going to put it in our calculator to get the answer negative 7 over 25. And they didn't ask for the tangent, but in order to do the tangent, the two 25s would cancel each other out. So I'll just underline them here. And so you would wind up with 24 over negative 7 if they asked for the tangent of 2 theta. For problem number 14, we've already done most of this on a different problem. So I subtract 1, 2 cosine x equals negative 1, cosine x equals negative 1/2, and then we know it's in quadrant number 2 and quadrant number 3 because all students take calculus. And then when I do inverse cosine of positive 1/2, it gives me the answer of 60. And so we get the answer of 120 and 240. Now because we got the answer of 240 is the bigger number, but they want this in radians, I'm going to multiply that by pi over 180. And that turns out to be 4 pi over 3. For number 15, x equals r cosine theta and y equals r sine theta. Now because this is in radians, you want to make sure you change your mode to radians and do -3 cosine negative pi over 2 and -3 sine negative pi over 2. Now the first one gives me an answer of 0, and this one gives me 3, so my answer is 0, 3. For the next one, they gave us one answer, and they want to know another answer, so I'm going to give you the other 3 that we would normally have. Well, if I do this and I go around the circle in the negative way, I get 3 square roots of 2, negative 30. Now the other 2 answers that I would have would be negative 3 square roots of 2, because we have 2 positive answers and 2 negative answers. Now when we have this graph, if this is 330, when I look over here, that is 150. Now when I go around the other side, that would be negative 210. We have r cosine theta minus sine theta is equal to 6. So r cosine theta minus r sine theta is equal to 6. Well, r cosine theta is x, and r sine theta is y, so we get x minus y equals 6. And this is problem number 17. Problem number 18, we'll use the same slide. To get r, we're going to do the square root of 0 squared plus 4 squared, which turns out to be 4. Now normally we would do arctan of 4 over 0, except for when I do that in my calculator, it tells me we're undefined and blah blah blah. So we can't do it this way. But if I think about it, 0, 4 is right here, and so that is 90 degrees. So my answer is either going to be 490 degrees, or if I need to change that to radians, depending on where the numbers are, we get 4 comma pi over 2. X squared plus y squared equals 6y. And we're supposed to write this in the polar. So there's r squared, and there's 6r sine theta, because this is the same thing as r squared, that's the same thing as r sine theta, but they both sides have an r that I can delete or divide by. So r equals 6 sine theta. And finally, for this video, if we have r cosine theta equals 4, well, this is the same thing as x, so x equals 4. My next video will do 21 through 30.